My name is Joshua Griffith. I'm representing the Silver team. We done the spray paint booth pressure system. The rest of the team is Ronnie Peoples and Josh Hutchison. A little bit of a background on the system. It's an engine assembly plant in Dunlap, Tennessee that has the spray booth. It's used to paint their engine housings. On our system, what we're running is just booth 1. Both of the other dampers are closed, so both booth 2 and booth 3 are not going to be used in our system. A little bit more background on it. Your input variable is your motor speed. So you increase the motor speed into the system, you output a different booth pressure, and that comes out in centimeters of water. The objectives of this presentation is to review what we had done with the steady state operating curve and the step response, which was in our previous presentation. We'll go over the FOPD Excel model and how it relates to our step response, and go into the alternative method, see how it relates to it, and compare the alternative method to Fit2, which we really didn't get to do, but I still have a few slides in showing what we will be doing with it. A little bit of the procedure. You have your operator input, which is your motor speed. It goes to your LabVIEW program, which operates the system itself, and then it sends the information back into the LabVIEW program, and then what we used was Excel to set up our spreadsheets and our graphs. This is a review of our steady state curve. This is just an example of how we've done several different output ranges on this. This was from, it looks to be 60 to 75% of our actual input range. You can tell, well, you can see it only takes a matter of maybe half a second for it to get to steady state. So we didn't need to really go full 15 seconds. 10 seconds would be fine. That's what we ran our other experiments at, was just at 10 seconds. On the steady state operating curve, it came out to 3 distinct ranges, which was our 3 distinct ranges we had for the system. On the first presentation, this was not modeled linearly, so we went back and changed that back to where it is modeled linearly. Changed our equation to the output would be equal to 0.64 times the input minus the 17.52. That's different from what we had from the previous presentation. This is how we collected the data for the gain, dead time, and the time constant that we used to set up our step response curves. Going into the step response, we got some averages for our gain. The lower portion, it seems like the gain didn't change much between the step up and step down, but when you got into the middle ranges and the upper ranges, the gain increased when you started to step down compared to what the step up was. You also can see that in the dead time, where there's more dead time in the step downs than what there would be in the step ups for our system. You can also see it in the tau in our system, the response times. And looking at these, it doesn't look like the error bars are so great that there's a lot of error in the system for the actual tau. This is where we inputted our FOPD model into our data that we have. The model itself is the blue line. Our data for this example is the purple, pink line, whatever you want to call it. But the model was set up.
Should look like fuchsia.
Fuchsia. The model was set up that you could input a desired start range. If you know you were going to start, say, at 73%, you input that and you can start it at that percentage. You put in the initial start percentage, you put in the step that of which you want to model. I'm trying to remember the rest of it. That just a minute ago. You put in the step that you wanted to model, put in the average K values, which we calculated earlier, put in the average dead time and the tau values, and the model should show, if you start with one input, it will show you that you should come up with the other output from that step. Like say step started at 5, step percentage was a 10% step in the power. It will show you, it will give you a pretty close model of what the output pressure will be at that step. That's an example of our step up. This is the same thing for our step down. Just another example of it. The alternative method, it was a little confusing to us. We're still working on it. This